Hi guys, this is a video tutorial for some problems from the book of Advanced Engineering Mathematics 5th edition. Our first problem is at page 107, number 63. Using variation of parameters, obtain a formula for a particular integral for each of the following equation. Our equation is y triple prime minus y double prime plus y prime minus y is equal to f of x. Now for the solution. First, set the equation into homogeneous. Now our equation would be y triple prime minus y double prime plus y prime minus y is equal to 0. Now we will get the roots denoted by m. Our auxiliary equation would be m cubed minus m squared plus m minus 1 is equal to 0. Now our roots would be n is equal to 1 and n is equal to plus minus I. From our roots, we can get our complementary solution. Now that would be yc is equal to c1 e to the x plus c2 cosine x plus c3 sine x. Now, to find yp using variation of parameters, yp is equal to y1 u1 plus y2 u2 plus y3 u3. y1 is equal to e to the x and y2 is equal to cosine x and y3 is equal to sine x. y1, y2, and y3 came from our complementary solution. To find u1, we should find u1 prime first. Now to find u1 prime, we should use the Wronskian method. Now, this would be the equation. Now, in getting Wronskian, we should find the determinant of this equation. And our u1 prime would be f of s over 2e to the s. Integrating both sides would give us u1 is equal to 1/2 of the integral f of s times e to the negative s. Now, in finding u2 and u3 are just like our u1. To find u2 prime, by Wronskian method, this would be the equation. And now our u2 prime would be e to the s times f of s times the quantity of sine s minus cosine s all over 2e to the s. Integrating both sides would give us u2 is equal to 1/2 times the integral of f of s times the quantity of sine s minus cosine s. In finding u3 prime, by same method, by Wronskian method, the equation would be like this, and u3 prime would be negative e to the s times f of s times the quantity of sine s plus cosine s all over 2 e to the s. Integrating both sides would give us u3 is equal to negative 1/2 times the integral of f of s times the quantity of sine s plus cosine s. Now, ryp is equal to y1 u1 plus y2 u2 plus y3 u3. Now, substituting the values from our equation would give us this equation. Now, simplifying the terms would give us, using the trigonometric identities, this equation would give us, and now ryp would be 1/2 times the integral of f of s times the quantity of e to the x minus s minus sine x minus s minus cosine x minus s. And that would be the final answer for our first problem. Our second problem is at page 111, number 14. Find the solution of each of the following equations which satisfies the given auxiliary conditions. Our equation would be x cubed times y triple prime plus 2x squared times y double prime plus x times y prime minus y is equal to 15 cosine of 2 ln of x. Our auxiliary conditions are y1 is equal to 2, y prime 1 is equal to negative 3, and y double prime 1 is equal to 0. Now in this equation, first we should set it into homogeneous and let y is equal to xm, y double prime is equal to m times m minus 1 times xm minus 2 times y prime is equal to mx to the m minus 1 and y triple prime is equal to m times m minus 1 times m minus 2 times x to the m minus 3. Substitute these values to the equation would give us this. Now in setting it into a homogeneous, it would give us like this. Now we should get the roots, also denoted by m. Our auxiliary equation would be like this. Now getting our roots would give us m is equal to 1 and m is equal to plus minus I. Now our complementary solution would give us yc is equal to c1x plus c2 cosine ln of x plus c3 sine of ln of x. Now to solve yp, we let yp is equal to a cosine 2z plus b sine 2z, where z is equal to ln of x. Now taking the first derivative of yp would give us negative 2a sine 2z plus 2b cosine 2z. The second derivative of yp is equal to negative 4a cosine 2z minus 4b sine 2z. And the third derivative of yp is equal to 8a sine 2z minus 8b cosine 2z. Now, replacing these values to the original equation would give us like this. Now, simplifying the terms give us sine 2z times the quantity of 8a plus 4b minus 2a minus b plus cosine 2z times the quantity of negative 8b plus 4a plus 2b minus 8 is equal to 15 cosine of 2z. Now, in getting a and b, we let sine 2z must be equal to 0 and cosine 2z must be equal to 50 cosine 2z. Now, from there, we can get our a and b. Now, our a would be equal to 1 and b is equal to negative 2. Substituting these values from our equation would give us yp is equal to cosine 2 ln of x minus 2 sine 2 ln of x. Now, our y is equal to yc plus yp. Substituting those values from yc and yp would give us this equation. Taking its first derivative of y would be this equation, and y double prime would give us this equation. Now, using the derivatives, we substitute our auxiliary conditions, and that would give us y to the 1 is equal to 2, which is equal to c1 plus c2 plus 1. And our first equation would be 1 is equal to c1 plus c2. Now, in y prime of 1 is equal to negative 3, which is equal to c1 plus c3 minus 4. Now our second equation would be y is equal to c1 plus c3. Now our y double prime 1 is equal to 0. Now it is equal to negative c2 minus c3 minus 4 plus 4. Now our third equation would be c2 is equal to negative c3. Since we have three equations and three unknowns, we should get c1 is equal to 1, c2 is equal to 0, and c3 is equal to 0. Now our y would be x plus cosine 2 ln of x minus 2 sine 2 ln of x. Now that would be the final answer of our problem number 2. Thanks